Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two word problems using the concepts of radian measure of angles. So as per the first problem, David made a swing for his niece Sarah using ropes 2.4 meter long so that Sarah swings through an arc of length 1.2 meters. Determine the angle through which Sarah swings in both radians and degrees. So the first step here is to draw a diagram for this problem. So it's a swing that goes back and forth. So we can draw it like this and this. So as the swing, so A is the point from which the swing is hanging. B is the point where Sarah sits, and it just goes back and forth. Now the rope in this swing is represented by side AB, so which is 2.4 meters, and it's also the side AC in this diagram, which is also 2.4 meters. Now the arc length is represented by this curve from B to C, which is 1.2 meter long. Now we have to determine the angle through which Sarah swings, and that is represented by this angle A, and we can use the variable theta for it. Now in order to find this angle theta, we have to use the formula for arc length, and the formula is theta equals A over R. So in this formula, theta is the angle in radians, A is the arc length, R is the radius, and A and R should have the same unit. Now we are given that the arc length is 1.2 meters and the radius is 2.4. So we'll sub in these values. So we get 1.2 over 2.4, which can be reduced to just 1 over 2 radians. So you have to keep in mind that in this formula, the unit of theta is radians. Now we need the answer in both radians and degrees. So we'll have to convert these radians to degrees. So for that, we'll multiply 1 over 2 radians by 180 degrees over pi radians. So here pi radian is in the denominator, and that helps us cancel out the radian unit. So when we multiply these fractions, so we get 180 over 2 pi. So when we multiply fractions, we multiply the numerator terms and the denominator terms. And this is in degrees, and this fraction can be reduced to 90 over pi. And 90 over pi can be simplified into decimal form using a calculator. So 90 divided by pi is equal to 28.6 degrees. So this is the angle through which Sarah swings in degrees. So we are done with the first word problem. So now we can analyze the second word problem. An engine on a jet aircraft turns at about 12,000 rpm. Find an exact value as well as approximate value for the angular velocity of the engine in radians per second. Now we are given the RPM of the engine. The RPM means revolutions per minute. So we are given that the engine turns at the rate of 12,000 revolutions per minute. Now we have to calculate the angular velocity in radians per second. Now angular velocity means the angle by which an object has rotated per unit of time. So there is a formula for angular velocity. So W, which is the symbol for angular velocity, is equal to theta over t, where theta represents the angle through which an object has rotated and t is the time it has taken the object to rotate by angle theta. Now in this case we are given that the engine completes 12,000 revolutions. Now we know that one revolution in radians is equivalent to 2 pi. We have to use radians because the unit of angular velocity should be radians per second. So one revolution is equivalent to 2 pi radians. So 12,000 revolutions, or I'll just write the short as revs, will be equivalent to, so we'll multiply 2 pi by 12,000, which is equivalent to, so 24,000 pi radians. Now these many radians are covered in 1 minute, and we know 1 minute is equivalent to 60 seconds. We want the unit of time to be in seconds because the unit of angular velocity should be radians per second. Now we can sub in these values in this formula. So the angle through which the engine rotates is 24,000 pi radians. So that goes in the denominator over the time in seconds, which is 60 seconds. Now we can reduce this fraction. So 24,000 divided by 60 is equal to 400. So we can simplify this fraction to 400 pi radians per second. So this is the exact value of the angular velocity of the engine in radians per second. Now to find the approximate value, we should use the value of pi and we should multiply by 400. So we do 400 times pi, which is equal to, so I got W equals, so 1256.6. So I'm rounding the answer to 1 decimal place. So this should be the approximate value for the angular velocity of this engine. So this should be the final answer for the approximate value. So these are the steps you have to keep in mind to solve problems like this one. So it's very important to understand the formula theta equals A over R for the first bird problem, and for the second problem we need to know and understand the formula that the angular velocity is equal to theta over time. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.